We'll start out before we do this problem. I prefer to use dimensional analysis, but did anybody, as they're going through these problems, I know the ones that were set up in the homework we had this week were set up to work well with the dosage calculation formula, but did anybody try the proportion method or the dimensional analysis method and come up with a favorite? Is there anybody that's like hung up on like the proportion or the formula? Okay. So if I'm using the dosage calculation for most of them, or the dimensional analysis for most of them, nobody's going to be terribly upset. That's good. If there is a problem that we do here today that you want to see done with one of the other methods, let me know and I will go back and do that. So anyway, for dimensional analysis, we will start out with what the doctor orders, 1,000 milligrams, and put it over 1. Make it a fraction. And then we're going to convert into what we can deliver. We use the label, which is, if we were referring back to the formula, that would be the on-hand dose in the vehicle. And we use that to convert it into what we're going to administer to the patient. So milligrams have to go on bottom here so that they'll cancel out. We have 300 milligrams. And that 300 milligrams is connected to 1 tablet. So the milligrams cancel out. 100 times, or 1,000 times 1 tablet is 1,000 tabs. Over 1 times 300 is 300. We divide that out, we get 3 1/3 tabs. If you left it like that for now, that would be fine because I didn't ask you to do any more. But you'll notice up here that this is scored tablets, which means what? Nearest half tablet. So 3 1/3 is between 3 and 3 1/2. Which is it closer to? It's closer to the 3 1/2, yes. Remember, 3.25 would be right in the middle here. So anything bigger than 3.25, and 3 1/3 is 3.33. So that's got to be closer to the 1/2. So I want to start out today with some more examples of this. Maybe step it up just a couple of notches at times. But let's take a peek here. We have an order for 0.15 grams of acid. Label on our bottle says 150 milligram capsules. So we start out with our order of 0.15 grams. Put it over 1. This one we run into an issue of the units in our doctor's orders do not match up with any of the units on the label. But can we convert the order, the grams, to one of the units on the label? And we can. We can convert grams into milligrams. Now, since it's metric, we don't really have to go through a conversion factor. We can just move the decimal point. Grams to milligrams is 3 spots to the right. Or remember that that milli is 1,000th. There are 1,000 milligrams in a gram. So 0.15 grams times 1,000 is 150 milligrams. Now we can go ahead and keep going. Milligrams. What's carrying our milligrams, or 150 milligrams in this case, is a capsule. 1 capsule. So the milligrams divide out. We've got 150 capsules over 1 times 150 is 150. And that, of course, divides out to 1 capsule. So the issue there was just converting the grams to milligrams, pretty much. So let's say you got an order for GR 1/4. What does that mean? 1/4 of a grain. Remember, G is gram, GR is grain. And for some reason, when they use grains, they tend to put it before the number. On our label, actually we have an option here. Now we're just going to use 30 milligram tablets. So the first thing we have to do here, we've got to take this 1/4 grain, we've got to convert it into milligrams. What's our relation between milligrams and grains? 1 grain contains how many milligrams? Do you remember? It's either 15 or 60. And I'm saying that because I'm a little foggy this morning too for some reason. One gram is 15 grains, 1 gram is 60 milligrams. So the grains cancel out. We have 1/4 times 60 milligrams is 15 milligrams over 1. And now we can go ahead and go through the process. We got 30 milligrams per tablet. Milligrams cancel out. We got 15 tabs over 30. So that's 0.5 tablets. Or a half tablet. So this is one thing I like about the dimensional analysis method, is if I do have to change units, I can just keep going right along. In fact, some would do this all as one problem. They would do the conversion here, 1 grain to 60 milligrams, and then milligrams to tablets. All at once. Cancel out the grains, cancel out the milligrams, multiply everything across the top. 1/4 times 60 times 1 tablet is 15 tabs. 1 times 1 times 30 is 30, and get the 0.5 or half a tablet. Which works pretty well. I've always been one that likes to do it step by step, but you can set it up as one big long problem like that and just multiply through the top and the bottom and divide it out. So let's say you have an order. Potassium chloride. What's 40 MEQ mean? Milliequivalent. Good. What's a milliequivalent? It's 1,000th of an equivalent. A milli means 1,000. It really doesn't matter. Because what we're looking at is on the label, we have that, 20 milliequivalents per 15 milliliters. So how big a milliequivalent actually is doesn't really matter, or what it is. We don't even know whether it's a weight of mass or volume. It is a unit of mass, by the way. It's almost like kind of like a milligram or a grain. It's a unit of mass. So we're going to take our order of 40 milliequivalents and put it over 1. I'm going to put milliequivalents on bottom here to get rid of them. And our label relates milliequivalents to milliliters. So milliliters will be on top. 20 milliequivalents to 15 milliliters. Now, if you like to cross-cancel in your fractions, you can cross-cancel the numbers here with the 20 and 40. I'm not going to, just because most of the nursing instructors prefer not to do it that way. So I've kind of gone along with it. But 40 times 15 is 600 milliliters. over 1 times 20 is 20. So 600 milliliters divided by 20 is 30 milliliters. Is what you would administer to the patient. You might have an order for 1,200 or 1,200,000 units of penicillin. And on the label, it says it is constituted at 100,000 units per milliliter. I want you guys to try that one for me quick. Work that one. So we start out with 1,200,000 units. I still use the abbreviation capital U for units. That's something that changed about 2 years ago. They want you to write out the word units now. And I don't know why. I don't know if every instructor is asking you to do that in the nursing program or whichever program you're in. But I know that was something that was told to me by one of the instructors, was to have you guys write out the full word units. I don't know if there was a mixing it up with something else or what it was. So over here, units are going to go on bottom. What's going to go on top? Milliliters. And now I can fill in the numbers. 100,000 units per milliliter, so 1 milliliter. Units cross cancel. 1.2 million milliliters over 100,000. That'll divide out to give us 12. Perfect. So we're going to administer 12 milliliters. Okay, so our next step is to start looking now at, rather than administering this in a single dose, what happens if we're going to administer it over time? And of course, if you're going to administer a medication over time, you're looking at an IV. So we're going to be talking about IV flow rates. IV flow rates can be expressed in one of a few different ways. And one of the first things we have to be able to do is to convert between those. So we're going to start out with just a simple order of 4,000 milliliters to be infused over 8 hours. What's our flow rate in milliliters per hour? Well, that's a pretty simple calculation. 4,000 milliliters over 8 hours. Just going to divide it out. 4,000 divided by 8 is 500 milliliters per hour. A little bit trickier might be to order 250 milliliters over 20 minutes. And I want my flow rate in milliliters per hour. Well, that's 250 milliliters over 20 minutes. First thing we have to do is we have to convert our minutes into hours. 1 hour is 60 minutes. Now, why did I put minutes on top here? Don't we usually put the units we get rid of on bottom? Well, they're already on bottom here, so for them to cross cancel in our fractions, they had to go on top over here. Now you can multiply that out. 250 times 60 is what, 7,500 milliliters over 20 times 1 is, actually that's not 7,500, it's 15,000, isn't it? Thanks. That is 15,000 there. And then 20 times 1 is just 20 hours. So we divide that out, it becomes 750 milliliters per hour. This is one, by the way, if you liked using proportions. I had mentioned last week, I use the dimensional analysis for 80 to 90% of the problems. And occasionally there's a problem that pops up where the proportion would be easier. I personally, unless I'm teaching it, never use a dosage calculation formula. It's just my style. I don't memorize formulas. I use basic concepts. But this is a problem here. It's one of those, 10 to 20% of problems where the proportion actually would lend itself real well here. Because you could look at it like this, 250 milliliters per 20 minutes. And you could set that equal to, we know that 1 hour is 60 minutes. So converting this to milliliters per hour, you're just converting it from 20 minutes to 60 minutes. And with that, you could cross multiply and divide. 250 times 60 divided by 20 would give you 750 milliliters per 60 minutes, or 750 milliliters per hour. So let's say we are ordered to give 7,200 milliliters over 8 hours. Now we want our flow rate in milliliters per minute. So we're still going to set this up. 7,200 milliliters over 8 hours. Now we're going to have to convert hours into minutes. 1 hour is 60 minutes. The hours are going to cancel out. 7,200 milliliters times 1 is 7,200 milliliters. 8 times 60 minutes is 480 minutes. Now to get milliliters per minute, we just have to divide that out. Gives us 15 milliliters per minute. Or we might have an order for 800 milliliters over 40 minutes. So this one, and again we're asked for milliliters per minute. So this one, we got our 800 milliliters, and it's already over minutes. 800 milliliters over 40 minutes. So it's just a matter of dividing it out. 800 divided by 40 is 20. That'll be milliliters per minute. Well, the next level would be to add a drop factor. What a drop factor is it's describing the thickness or the viscosity of the fluid. And it is saying literally how many drops of that fluid it takes to make 1 milliliter of liquid. Generally, drop factors will range from, well, for medical purposes, usually from around 8 to 20. I've seen drop factors in substances go as low as like 4 drops per milliliter and as high as about 50 drops per milliliter. But most of your medicines, like I said, are between that 8 and 20 drops per milliliter range. So that's what our drop factor is describing for us. So let's say we are ordered 4,000 milliliters over 8 hours. The medication that is labeled with a drop factor of 12 drops per milliliter. GTT is, again, our abbreviation for drops. And we want to know our flow rate in drops per minute. So 4,000 milliliters over 8 hours. So we've got a couple of things we got to deal with here. We have to convert our hours into minutes. 1 hour is 60 minutes. So our hours have now canceled out. Right now we've got milliliters on top and minutes on bottom. So we're in milliliters per minute. So we have to get rid of those milliliters. So I'm going to do something over here. Milliliters are on top, so to get rid of them, I'm going to put milliliters on bottom. And the relationship I have for milliliters is right here. I have 12 drops per 1 milliliter. Per milliliter means per 1. So now my milliliters will cancel out. I have to go down here. 4,000 times 1 times 12 is 48,000 drops over 8 times 60 minutes times 1 is 480 minutes. If we divide that out, we're going to get a whopping 100 drops per minute. That's a bit of a rapid infusion there. I'm going to have you guys try one of those. So we're going to give you an order for 3,600 milliliters over 12 hours. Label gives us a drop factor of 15 drops per milliliter. Find our flow rate in drops per minute. So we'll start out with our order of 3,600 milliliters over 12 hours. I'm going to go with the hours first. I could go with milliliters first, it wouldn't matter, but I've always been in the habit of doing the drop factor last. Partly because sometimes you want milliliters per minute, sometimes you want drops per minute. So I always get it to milliliters per minute first and then convert. So 1 hour is 60 minutes. So I've got rid of the hours. Right now my top unit is milliliters, my bottom unit is minutes. So I would be in milliliters per minute. So I'm going to put milliliters on bottom to get rid of the milliliters. I have 15 drops per 1 milliliter. So the milliliters are gone. Now I have drops on top, minutes on bottom. So I would be in drops per minute right now. So 3,600 times 1 times 15 is 54,000 drops. Over 12 times 60 times 1 is 720 minutes. We divide that out, we get 75 drops a minute. What everybody else got? Good. This is, again, another one of the reasons why I like using dimensional analysis. Because for IV flow rates, dimensional analysis is the way you have to go. All you're doing is converting units. And we can add another level of complexity to this, and dimensional analysis can still handle it all in one little sweep. for example, let's say the doctor orders 12,000 milligrams to be administered over 6 hours. And the label states that it's constituted of 15 milligrams in 4 milliliters. And a drop factor of 10 drops per milliliter. This one starts out very similar to our other ones, only it's not milliliters per hour, it's milligrams per hour. 12,000 milligrams over 6 hours. Now, I'll be honest with you, I would be very tempted. Well, I wouldn't be tempted, I would do. At this point, I would actually divide out the 12,000 by 6 and get 2,000 milligrams per 1 hour to get some smaller numbers up there. But you don't have to do that. So now I'm still going to convert. Now I have to convert both my hours to minutes and my milligrams to milliliters somehow. I'll do my hours first. 1 hour, 60 minutes. So my hours are gone. Right now I am in milligrams per minute. Now I have to get rid of milligrams. So that's got to go on bottom. What equivalency do I have for milligrams? Well, I have 15 milligrams in 4 milliliters. So 15 milligrams on bottom, 4 milliliters on top. So my milligrams cancel out. Now I have milliliters on top and minutes on bottom. So this would be milliliters per minute. So my next step, I'm going to use my drop factor. Put milliliters on bottom, drops on top. 10 drops per 1 milliliter. And the milliliters are now gone. Now I have drops on top and minutes on bottom. I am in drops per minute. So I'm going to multiply this out. 12 times 1 times 4 times 10 drops is 480,000 drops. Over 6 times 60 times 15 is what? Is that 5,400? Is that right? Minutes. So now I'm going to divide out 480,000 divided by 5,400. 88.89 drops per minute. At this point, I'm going to have a little bit of a discussion on rounding. Depends on what you're using to infuse. If you are setting this manually, you just go to the nearest drop. So I was doing this manually, that would just simply be 89 drops per minute. If you're using an electronic infuser, depends on the device. Usually it's either 1 or 2 decimal places. So if it was an electronic infuser, it's either going to be 88.9 or 88.89 drops per minute. For this class, any one of the 3 is acceptable. If you round to the nearest drop, that is fine with me. Otherwise, 1 or 2 decimal places. Never go more than 2 decimal places. There's never an application where you need to be down to the 1,000th of a drop. Okay, let's take a peek. Let's have you guys do one with the milligrams. So let's say you are given an order to administer 1,800 milligrams over 8 hours. Our label is 25 milligrams in 2 milliliters, and a drop factor of 8 drops per milliliter. So give this to me in drops per minute. See what you come up with. So we'll start out with our 1800 milligrams over 1. Sorry, over 1. Over 8 hours, right? Gotta wake up here. 1800 milligrams over 8 hours. So I either change milligrams or hours first. Doesn't matter. Let's go with hours. 1 hour is 60 minutes. So I've changed the hours. Now I have to change because I want my time to be minutes. So I should say minutes. Looks kind of like milliliters. I want my time to be in minutes. So I'm going to leave that as minutes. All I can change now is the milligrams. And again, I have a relationship between milligrams and milliliters. 25 milligrams and 2 milliliters. Milligrams are now gone. But I want it to be drops per minute, not milliliters per minute. So I have to get rid of the milliliters. Milliliters go on bottom. It's going to be 8 drops per 1 milliliter. So the milliliters are now gone. So now we do have drops over minutes. On top here, we are going to multiply 18 times 1 times 2 times 8. Which is going to give us 28,800 drops over 8 times 60 times 25, which is, what, 12,000 minutes. So 2,800 divided by 12,000. Oops. I'm just leaving out some zeros. 2.4 drops per minute. Is that what you came up with? That might be running a little slow. Oh, well, that's what I get for making up my examples on the fly. Any questions so far? That would be a tough one because obviously 2 drops per minute if you're doing it manually. You're losing, 0.4, you're losing, that's like 16 or 17% of the dose is being lost if you round that down to 2. So that'd be a tough one. I'm not sure. You'd have to ask one of the core instructors how to handle that. I'm sure there probably are medications that run close to that slow, but I couldn't think of any examples right now. Okay, well, let's look at one. We're going to add just one more level to this, and then we'll move on. So let's say you have an order for 500,000 units over 12 hours. Our label so there's 100,000 units in 1 gram. It is constituted 250 milligrams in 20 milliliters. And drop factor of 10 drops per milliliter. So we're going to start out with our order here of 500,000 units. $12. I'm going to get rid of my hours first again. 1 hour being 60 minutes. And now I do have to get rid of units. Here's where I'm going to cheat a little bit. Label says 100,000 units in 1 gram. But we know that in our next step, we're not going to need grams. We're going to need milligrams. So here, I'm going to do 100,000 units. But instead of putting them in 1 gram, 1 gram is how many milligrams? 1,000. There's 1,000 milligrams in 1 gram. So I'm going to put 1,000 milligrams in there. So I have canceled out the units. I'm now in milligrams per minute. My next step, I'm going to cancel out milligrams, go to milliliters. And I have 250 milligrams in 20 milliliters. So I'll cancel out my milligrams. I now have milliliters on top and minutes on bottom. So it'd be milliliters per minute. So my next step, I'm going to get rid of milliliters and go to drops. I have 10 drops per milliliter. So the milliliters are gone. Now, if you go to punch this in your calculator, many of your calculators are going to either struggle with the zeros or throw you into scientific notation. To avoid that, I am going to go ahead and cancel some zeros. So I'm going to do is this, and I usually cancel them 3 at a time, just because it's easier that way. So I've got 3 zeros here. I'm going to cancel with 3 zeros here. I've got 1 here that'll match up with 1 there. That I can do easily. I've only got 2 zeros here, so I'm going to take these 2 and this 1 to cancel out those 3. It looks like that's probably as far as I'm going to be able to go with canceling zeros. So we've got 500 here times 1 times 1 times 2 times 10. So that's 1,000. That's 10,000 drops. Then bottom at 12 times 6 times 25 times 1. So what does that end up being? 150, 1,800. Does that look right? Minutes. So we're going to take 10,000 divided by 1,800. 5.55, 5.56 drops per minute. So you can see they can get kind of crazy. But again, here's a power of that dimensional analysis. I could have used the dosage calculation formula here. But first, before I could even use the formula, I would have to convert this into units per minute. Then I would use the formula. The dosage calculation would take the units to milligrams. Then I would have to apply the dosage calculation formula again to go from milligrams to milliliters. And then I'd have to apply it again to go from milliliters to drops per minute. So the dosage calculation formula works, but you have to do it over and over again. The dimensional analysis, technically I did do 4 dimensional analysis conversions here. But I do them all at once. Okay, I'll stop preaching. Our next step is we're going to start talking about dosages. Yes?
Are you going to have any problems with how many zeros?
There might be. Not on the test that we're going to take. There won't be. But I will tell you right now, the examples that I am doing in class here come right off of the practice tests in the ADN program. So yes, you will have problems in the program that have that many zeros in them. Okay. I'm a little bit nicer than that on the tests we do in here. But so let's look at dosages based on weight or mass. Whenever we say based on weight, we are generally saying based on mass as well. Because, as we mentioned, in the standard system we use weight, and the metric system we use mass. So the first thing we have to do is look at our labels. Most of our labels are going to be stated in metric units. So our label might give a recommended dose of 4 milligrams to 5 milligrams per kilogram per, might say, day. So since these are per kilogram, the first thing we have to do for any patient that comes in the door is to convert their weight to kilograms. If you asked a patient their weight, very seldom, I mean, if I asked one of you your weight, and you don't have to say it, how many of you would know your own weight in kilograms right now? Not off the top of your head, right? So if a patient comes in with a weight of 180 pounds, the first step we have to take is to convert that weight into kilograms. Now, we do this often enough, I don't want to have to set up the dimensional analysis all the time. We're going to do it once here, and then we're going to use that to establish a pattern. So we put 180 pounds over 1. And in our conversion factor, pounds will go on bottom, kilograms on top. Does anybody remember the relationship between kilograms and pounds? 1 kilogram is 2.2 pounds. So the pounds cancel out. This is 180, and you can see it's going to be 180 divided by 2.2. You know, it's 81.82 kilograms. So because the 2.2 is on bottom, we would just be dividing the 180 by 2.2. Things to keep in mind. A kilogram is larger than a pound. So when you are converting from kilogram or from pounds into kilograms, units are getting larger. So that means the number must do what? Must get smaller, must decrease. So if you ever go from pounds to kilograms, and the number with the kilograms is bigger than the number with pounds, you know you did something wrong. Now, I'm not throwing that out there to make fun of you or make light of anything, but those are little things I keep in my head all the time, because it is very easy to screw up, especially since on the calculator, divide and multiply are right next to each other. I mean, even if you're thinking the right thing, it's very easy to hit the wrong key and multiply by 2.2 instead of divide. Or going the other direction, if you do for some reason have to go from kilograms to pounds, you know, pounds are a smaller unit, the number must get bigger. And so again, it's very easy to, I'm always dividing by 2.2 when I convert. It's very easy to make that conversion backwards. So if a patient comes in with a stated weight of 253 pounds. The quick method of converting them is we know that we're going to divide by 2.2, which gives us how many kilograms? What's that? 115. Perfect. Okay, it is time for our break. So let's go ahead and take our break. When we come back, we will discuss dosages based on weight.